So we're now on the back of the notes, and the question we have to answer here is how do you factor using the greatest common factor? So, first of all, what is factoring? Factoring is simply unmultiplying. So when we multiply something like 2 times x minus 3, this is what we did before, we used distribution. We did 2 times x and got 2x, and we did 2 times 3 and got minus 6. So now we're going to be going backwards. We're going to be given something like 3x minus 12, and we're going to be asked to find the original products. What did we multiply together to get 3x minus 12? So another way of thinking of this is simply as undoing the distributive property. So number 1, we're going to look at 4x squared plus 6x. Now this is a second degree binomial. So when we're looking for our greatest common factors, we have to take into account both parts of the polynomial. So both terms, we have 2 terms here. So one way we can do, like we saw earlier, is we can break this down into its prime factors. So 4, the prime factors of 4 would be 2 times 2. The prime factors of x squared are x times x. So 2 times 2 times x would make up 4x squared. Now 6x, the prime factors of 6x would be 2 times 3 times x. So now we need to find the common factors. So they have a 2 in common, and they have one x in common. So our greatest common factor is going to be 2x. So now we have to figure out what did we multiply 2x by to get 4x squared plus 6x. Well, 2x times, 2 times 2 is 4, and x times x is x squared. And notice those showed up right here as our leftover numbers, 2x times 2x. For 6x, to multiply to get 6x, we'd have to do 2x times 3. And again, notice that popped up when what wasn't in common. So this right here would be our final answer, 2x times 2x plus 3. Now, you might be asking, why couldn't we have just said 2 times 2x squared plus 3x? Or why couldn't we have just done x times 4x plus 6? Well, the reason these two answers are inaccurate is because they have a common factor. They both, this one shares an x, and this one shares a 2. So we don't consider this factored completely because they still have a common factor. You have to get the greatest common factor out when we reverse multiply. When we're undoing the multiplication, we're trying to find the biggest number that we can take out of both terms. So looking at number 2, this time we're going to look at a trinomial. So that trinomial is going to be 3x squared plus 12x minus 24. So what we're going to do is we're going to figure out all the prime factors of these 3 terms. Now remember, this time we have a trinomial with 3 terms. We have to find a common factor, if possible, for every single term. So 3x squared is 3 times x times x. 12x would be 2 times 2 times 3 times x. Because remember, 12 is 4 times 3, and 12 would be 2 times 2 times 3. Now 24 would be 2 times 2 times 2 times 3. And remember, if you need to make the factor tree, you're welcome to do so. You can just do it out to the sides. If you can't remember how to do 24, you could just break it down, and you could say, oh, that's 3 and 8. 3's prime, 8's not. That's 2 and 4. And you could sit here and do this. That would be fine. Or if you already know the factors, you can just write them out. Now we're looking for a common factor. So off the bat, I can see that all three have a 3 in common. Now we cannot use x as our greatest common factor because 24 doesn't have any x's to give. Every term has to have a common factor. So what that means is our greatest common factor is simply 3. And that's okay. It can have only one number in common. So now we're going to write down what's left. 3 times what gives 3x squared? So that would be x squared. So 3 times x squared would give us 3x squared. Notice we have the 2 x's left here anyway. Plus 3 times 4x would multiply to give me 12x. And 3 times negative 8 would multiply to give me negative 24. So I'm simply undoing my multiplication. And the great thing about these is you can check. Notice x squared, 4x, and 8 have nothing left in common. If I was to re-multiply this out, 3x squared, 12x minus 24, I get the answer that I started with. So that's 2 ways you can know if you've done it correctly. So I want you to try number 3. So the problem is going to be 4x to the 5th minus 6x cubed plus 10x squared. So I want you to pause the video. When you think you have an answer and you want to check it, go ahead and turn it back on. Alright, hopefully you're ready to check your answer. So number 3's answer is 2x squared times 2x cubed minus 3x plus 5. So you should have found that your greatest common factor is 2x squared because 4, 6, and 10 are all even. So the biggest number they're divisible by is 2. And then they all share x squared. Okay, so if you didn't get this one right, you might want to put a little frowny face so I know you missed it. If you got it right, give me a little smiley face. So smiley face means I got it right the first time. Frowny face means I didn't get it right. And maybe Miss Miller needs to tell you a little bit more about number 3. So let's look at number 4 now. So negative 14x minus 21, whoa, my pen's going a little crazy here, sorry, minus 21y. Now this problem's a little bit different because it's in standard form because x comes before y, they both have a degree of 1, but what makes this a little different is that the leading coefficient is negative. So one of our rules with factoring is we never leave the coefficient on the leading term as a negative. We always factor that negative out. So to do that, we just simply remove the negative. So before we do that, however, we need to figure out what else they have in common. So 14 and 21 both have a 7 in common. So when I factor out the 7, I'm going to tag on a negative. So what's left when I take out that negative 7? Well, negative 7 times 2x give me that negative 14x. Now when I take negative 7 out of negative 21, I'm left with a positive 3. So positive 3y. And if you multiply it back, negative 14x times plus negative 21y would give me my original answer. So let's make yourselves a note down here because this is really important. Okay, the leading coefficient must be positive. So that means you're going to have to factor out the negative. Okay, that's very, very important. We never leave the leading coefficient to be a negative. So let's look at number 5. So number 5 is going to be negative 8x squared minus 12x plus 4. So again, we're going to try to do this one without breaking it down into factors. So the first thing we should notice right off the bat is we have a negative here. So we know we're factoring out a negative. So now we're going to look at our 8, our 12, and our 4. So 8, 12, and 4, they're all divisible by 2, but they're also all divisible by 4. And since 4 is bigger than 2, we're going to take out a 4. I'm then going to look and see if I have any common x's. So this one has x squared, this one has x, and this has no x's. So no x's can come out of this polynomial. So we're going to take out a negative 4. So when I multiply it back, negative 4 times what gives me negative 8x squared? Well, that would be 2x squared. And notice negative 8x squared. Negative 4 times what gives me negative 12x? That would simply be a positive 3x, because a negative times a positive would give me a negative. And then negative 4 times what gives me positive 4? Well, that would be a negative 1. So this would be my factored polynomial. Notice 2x squared, 3x, and negative 1 have nothing else in common, and negative 4 when multiplied back would give me the original polynomial. So number 6, I want you to, well, I guess we'll do number 6. No, I'll let you try number 6. So number 6, I'm going to let you try this one. If you get stuck, that's okay. Just turn the video on and I'll help explain it out to you. It's going to be a binomial. So I want you to see if you can factor out number 6. And when you're ready, turn the video back on. Alright, if you're ready, I'm going to show you the answer here in just a second. So our answer is negative xy squared, which is our greatest common factor, and our leftover is going to be 12xy minus 5. So if you looked, 12 and 5 have nothing in common, but we have to take out this negative. So in effect, we're taking out a negative 1. And then of course, hopefully you notice that we have 2 x's here and an x here, so 1x comes out. And we have 3 y's here and 2 y's here, so 2 y's come out. So again, if you got this one right on the first try, I want you to put a smiley face. If you got it incorrect, put a frowny face so that you'll remember to ask me questions, or that I can know that you need a little bit more help on this problem. Number 7. 2/3 y to the 4th plus 1/3 y, whoops, I'm going to change that to y cubed, minus 4/3 y squared. Now this one looks pretty nasty, but remember, we don't always like fractions, but we can always get rid of them, and this time we're going to get rid of the fractions by taking them out of a factor. Okay, so now we can't just multiply everything by 3 because this is not an equation. I know a lot of students that want to do this, they want to say, oh, we can just multiply it all by 3, and that would change it to 2y to the 4th plus y cubed minus 4y squared. That would only work if this was equal to some sort of number. It has to be an equation. We cannot change the value of the expression. So since this is not an equation, instead, we're going to simply take out the 1/3 by factoring it. So to do that, we're going to just say, okay, we can take 1/3 out of each of these. Now we need to look and see if they have any other factors in common. If you notice, they all have y's. So this one has 4 y's, this one has 3 y's, and this one has 2 y's. So the most y's I can take out are y squared. So I'm going to be factoring out a 1/3 y squared. And when I do that, I'm left with, well, 1/3 times what gives me 2/3? That would be 2. And then I'd have 2 y's left. 1/3 times, well, 1. And I can write the 1 and just put 1y, or I can just write y. And I tend to like to just write y. And then minus 1/3 times 4, and then the y squared stay. So this right here would be my factored polynomial. And this would be a little bit easier to work with if I was solving a problem. All right, let's look at number 8. 4x squared y squared plus 12x squared y minus 8x y squared minus 4x y. So this one's kind of a big one. It's got 4 terms, but I think you can do it. So what I want you to do is I want you to pause the video, and when you're ready to see the answer, turn it back on. All right, hopefully you're ready to see the answer. So 4xy is the greatest common factor, and then you're left with xy plus 3x minus 2y minus 1. So again, if you got this one right, give me a smiley face. If you didn't get it right on your own, give me a frowny face, and we'll talk about it a little bit more tomorrow if you're having trouble. Okay, so let's look at number 9. So this one's going to look a little crazy. We're going to have x times x plus 1 minus 2 times x plus 1. Now, this is a little crazy. It's still terms though, okay? So this right here is a term, and this right here is a term. Now your instinct may be to multiply them out. And that's a good instinct because normally we would, but there's something very important here that you need to realize. X plus 1 and x plus 1 are a common factor. And this is nice because that means we can bring that out. It's the greatest common factor here. They're in common. So what we can do is we can simply say, okay, x plus 1 is a factor of both of these, because this is x times x plus 1, and this is 2 times x plus 1. And then what we have left, well, what times x plus 1 gives me x times x plus 1? That would just be an x. And then negative 2 times x plus 1, well, x plus 1 times negative 2 gives me this negative 2. So what I've just done is I've just factored that very simply by not distributing those numbers there. I was able to find a common factor right off the bat. So always check, even if it looks a little strange, and see if there's any common factors there. So last one, I want you to try number 10. Again, it's going to look a little strange, but I want you to see if you can do it. So x times y minus z plus w times y minus z. So when you're ready, turn the video back on, but at this moment, go ahead and pause it. All right, hopefully you're ready to see the answer now. So the greatest common factor between these two terms was y minus z. So notice that's the first thing I brought out. I grabbed out my greatest common factor. And then what was left was x plus w. So again, if you got this one right, give yourself a smiley face. If you got it wrong, give yourself a frowny face so we can talk about it tomorrow. So you are now at the end of the notes. These need to go in the notes section of your notebook. And if you have any questions, make sure you make a note so that we can answer them tomorrow.